Hey guys, welcome back. In this tutorial, we're gonna learn how to find LCM using prime factorization. So what is LCM? LCM stands for least common multiple. So let's just take a simple example here. Let's say we have 3 and then 4. If we want to find the least common multiple, what I'm gonna do is I am just gonna write all the multiples of 3 and then all the multiples of 4, or the first few multiples. So what are the multiples of 3? Of course, it's 3 itself, 6, 9, 12, 15, and so on. And then I'm going to list some multiples of 4 as well. So it's going to be 4 times 2 is 8, 12, 16, 20, and so on. So we'll start from left to right, from the smallest number to the larger number, and then we'll circle the ones that are common in both. So here we do see 12 is common in both, and it's the smallest one going from left to right. Let's say if you have more numbers here that are matching, that are multiple of 3 and 4, we just want to find like the smallest one. So the least common multiple of 3 and 4 is just 12. So we can use this method to find least common multiples by listing multiples. But there is another way of finding least common multiple, and that's called prime factorization. So let's start with our numbers again. So I'm gonna write 3 and 4 again. And now here I'm gonna use prime factorization to find the LCM, or least common multiple, between these two. So what we're gonna do is we're gonna break down these two numbers into their smallest prime factors. So 3 in this case is already broken because 3 is a prime number. So let's say, what are the prime numbers from 1 to 10? So it is 2, 3, 5, and then 7, and then so on. So prime number is a number that is divisible by 1 and itself. So for example, 2 here is divisible by 1 and then 2. Same thing with 3, 5, and 7. So from 1 to 10, we have 4 prime numbers. So 3 in this case is already broken, it's already a prime number. So we'll just stop here. And then 4, we're just going to start drawing this tree here. So 4 can be rewritten as 2. Start with the smallest prime number. So 2 is the smallest prime number. So see if you can break down 4 into multiples of 2. So 2 times 2 is 4. So we'll just stop here. So now 3 can be just written as 3 times 1, because any number to the power 1 is just that number. And then 2 can be rewritten as 2 times 2. So 2 to the power of 2, because 2 times 2 just means 2 to the power 2. And now what we are going to do is we are just going to simply multiply all the distinct prime numbers, but we'll pick like the biggest one from both. In this case, we only have one prime number, so we'll just multiply them. So this will just be 3 times 1 into 2 times 2. So this just becomes 2 times 2 is 4, 4 times 3 is 12. So 12 is the answer using prime factorization. Now let's take a different example. Let's find LCM of 4 and 18 using prime factorization. So now 4, again, we are gonna break it down into its prime factors. So start with 2 always, because 2 is the smallest prime number. So 4 can be rewritten as 2 times 2. And once we get to this point where we have broken it down, you just stop there. And let me just highlight them. And now let's break down 18 into its prime factors. So 18, start with 2 again. So 18 can be rewritten as 2 times 9. Now 9 can be further broken down. So 9, we cannot divide 9 by 2, but it can be broken down into multiples of 3. So we can say 9 is 3 times 3. Now it has already been broken down into its prime factors, so we'll just circle them. We'll just stop here. So we got 1 of 2, and then we got 2 of 3. So this can be rewritten as, we have 2 to the power of 2. Here we have 2 to the power of 1 times 3 to the power of 2. Now we'll find the prime factors with the highest power from both. So here is 2 times 2, and here's 2 times 1. So we'll pick this one, because this has power of 2. This is bigger, so we'll ignore this and we'll pick this. And same thing here, since we only have one of 3's here, we'll just pick this one. So this just becomes 2 to the power of 2 times 3 to the power of 2. So 2 times 2 is 4 and 3 times 3 is 9, and this gives us 36. So the LCM of 4 and 18 using prime factorization is 36. Now let's do a bigger number. Let's just do 48 and 15. So we'll find the LCM of 48 and 15 using prime factors. So 48, we'll start dividing it by the smallest prime number. So we know this can be divided by 2 because it ends in an even number. So this can be rewritten as 2 times 24. On the left side, we can just stop here because we already have the smallest prime number. But here we can further break it down. So 24 we can further divide it by 2. It can be rewritten as 2 times 12. And then 12 can be rewritten as 2 times 6. And 6 can be rewritten as 2 times 3. We'll stop here because we have now broken it down into the smallest prime factors. Now let's do 15. We can't divide it by 2, so we'll start with 3, the smallest prime number. So 15 can be rewritten as 3 times 5. And we'll stop here because we have already broken it down. And let's just highlight both of them. Now let's just take all the numbers here, all the prime numbers here, all the prime factors, and write their powers here. So 2, how many 2's do we have here? 1, 2, 3, 4. So we can just rewrite this as 2 to the power 4 times, we only have 1 3 here, so 3 times 1. And then 15 can be rewritten as 3 to the power 1 times 5 to the power 1. Now let's just pick each prime factor from both the groups with the highest power. So here we have 2 to the power 4, we'll pick this because we don't even have 2 here. Then 3 is common in both and with the same power, so we can pick any one of them. If there's a tie, we'll just pick any one of them. And then 5, there's only 1. So this just becomes 2 times 4 times 3 times 1 times 5 times 1. So this just becomes 2 times 4 is 2 times 2 is 4, 8, and then 16. So 16 times, and 3 times 5 is 15. So this just becomes 240. So the LCM of 48 and 15 using prime factorization is 240. Now let's just do one more example, and this time we're gonna find the LCM of 3 numbers. So 6, 9, and 24. So I'm just gonna list them all here, and then let's start breaking it down. So we know 6, we can divide it by 2, so it can be rewritten as 2 times 3. 9, we can't divide it by 2, so we'll start with 3. So we can rewrite this as 3 times 3. And then 24, we can divide it by 2 because it ends in an even number, so we know we can divide it by 2. So this can be rewritten as 2 times 12. And then this one we can further divide it, we can further break it down. We can say this is equal to 2 times 6, and then 6 is just 2 times 3. Now let's just highlight all of our prime factors from each one of them. So I have a 2 here, and then 3, 3, 3, 2. So this just becomes 2 to the power of 1 times 3 to the power of 1. And here we have 3 to the power of 2, and then here we have 3 of 2's. So this is 2 to the power of 3 times 3. So now let's just pick all the prime factors here with the highest power. So let's start with 2. We have 2 to the power of 1, but here we have power of 3, so we'll pick this one. And then 3, we have the power of 1, and then 2, so we'll pick this one instead. And we'll just ignore this one because this can be rewritten as 3 to the power of 1. So now we have 3 to the power of 2, so this is just 3 to the power of 2 times 2 to the power of 3 equals to 3 times 3 is 9, so this just becomes 72. So the LCM of 6, 9, and 24 using prime factorization is 72. If you found this helpful, please leave a like and subscribe to my channel, and let me know if you guys have any questions. Thank you for watching.